Hey again everyone. It's the middle of June 2023 for any time travelers watching this. That doesn't mean the information is going to be out of date in this video, but I just wanted to plant it in time. Things change so rapidly in this area that it can be difficult to recall the state of things at any particular period. Today's video is the result of me being asked a simple question. What's the best way to run one of these large language models on my computer? The answer to that is this tailspin into a vortex of frustration and near insanity. I've had to re-record bits of this as packages were updated and bugs were fixed and new ones were introduced. Right now it's possible to run many large language models on high-end consumer-grade PCs, and there are available demo applications like Sherpa for Android showing the llama-cpp models running on high-end mobile phones. In the case of mobile phones, it appears that development is still in early stages and doesn't support the latest quantized model formats, and the performance is quite slow, but the proof of concept is out there. Before you get too excited, it may work, but none of it works very well. For PCs, I can't really keep up with where things are at. There is apparently a new quantization method for the GGML models coming out, but it isn't integrated into the text generation web UI yet. These are the K-quants. I've been able to run a few of the 30 billion parameter models on my mid-tier computer. This is a 6-core Intel i5-8400, I think, with 32 GB of RAM and a 12 GB NVIDIA RTX 3060 GPU. To compensate for the lack of RAM, I have 64 GB of dedicated swap space. It's slow, but my board is maxed out at 32 GB of RAM anyway, so this is the only way I can really load things. I'm not a machine learning expert by any means, so I'm going to try my best to avoid the strings of acronyms and jargon that surrounds this kind of thing. I want to try and come at things from an informed user perspective here. I'll go over some of the larger models later on when I show some of them running in the text generation web UI and show the methods needed to load them. In addition to the text generation web UI, there are a couple other user interfaces for interacting with large language models out there now. So far, for my limited use, I haven't really found any fault in the text generation web UI, but I've been poking at these things for a while and got used to using shell scripts and command line applications. The three main UI projects seem to be the text generation web UI, the LLM UI, and KoboldAI. Kobold has been around for a long time as an interactive tool for storytellers to use large language models, but hasn't been playing keeping up with the Joneses in regards to supporting new models and loading methods. The Kobold CPP wrapper is needed to load the new llama-cpp GGML models. One of the first questions that came to my mind, and probably yours as well, is how large of a model can I run on my hardware? The answer to that is an annoying "it depends." In full precision models, you'll need a couple gigabytes of VRAM more than the file size of the model. Quantized models, and I'll be focusing mostly on 4-bit models here, can be loaded differently depending on the UI support and the model type. Right now the major divisions seem to be AutoGPTQ and GGML. There's an older GPTQ method out there called GPTQ for Llama, and you may still find models in this format. To load these models using the TextGen web UI, see the flags on the Git page. GGML models can further be categorized into the original method models, who typically have file names corresponding to the quantization method, such as Q40, Q41, Q50, Q51, Q80, etc. Unless otherwise mentioned, assume that I'm using the original method 4-bit quantized model. Most of the models I download are converted by someone on Huggingface called TheBloke. For months they've been processing and uploading quantized models. I'm going to try to follow the terminology used in their README files to try to keep things as simple as possible. These require you to install llama.cpp libraries released after May 19, 2023. The newer models known as K-quants are not yet supported in many of the UIs as of this video. The method was released in the first week of June and support is still coming. The new models can be slightly smaller while still maintaining most of their output quality. Both AutoGPTQ and GGML models can be loaded partially into GPU VRAM and partially into system RAM. Currently it seems that splitting the GGML models between the CPU and GPU is a little faster than AutoGPTQ for the same converted models. With that in mind, I've tried to stick with GGML models for this, just because sticking to one set of libraries and hacks usually means fewer things to break. Although the interface looked clean and simple to use, I had no luck getting the Lord of Large Language Models UI running. For the video, I'm not really interested in living out Starship Troopers hunting bugs. If something doesn't work, I do my best to make sure I didn't idiot something up while going through the documentation, but I really don't want to bug hunt. Sure, there's a Discord group, but, I don't want to. I don't want to invest 6 hours into getting something running only to have it break the next pull. Because that's basically what happens with dealing with half the machine learning projects out there. Some of the LLM UI started working the next day, after pulling the updated source and reinstalling. However, my model options were limited here. When using the GGML models, I need to load about 10 GB onto VRAM and the rest into system RAM. There doesn't appear to be any simple way to pass split loading options to the Python CPP model pipeline or specify the number of CPU threads to use. So the whole GGML model tries to load onto my limited 32 GB of system RAM and run on my weak i5-8400 CPU. Very slow and not ideal. Similarly, there doesn't appear to be a way to specify how AutoGPTQ models are loaded. So here I can only load models that will fit fully onto VRAM, and can't split anything into RAM, once again limiting my options. If I stop running into bugs and can load models with other methods, I'll take another look at the LLMs UI. Right now, the current limitations make it a little too cumbersome for me to use. The TextGen Web UI offers offloading for either type, and Kobold CPP can be used to load the GGML models with KoboldAI, so I'll probably focus mostly on those two projects for the rest of this video. To get the recent GGML models loaded using the text generation web UI, make sure you've updated to a recent version of the source and install the updated requirements. Uninstall the current llama-cpp-python library and then install it again with GPU support using the on-screen commands. These come straight from the documentation for the web UI. AutoGPTQ support is already installed with the ability to do CPU offloading when the requirements for the web UI are installed. Models can be downloaded directly from the text generation web UI through Huggingface. I don't have many GPTQ models to test, so I'll grab one for later. The GPT for all 13 billion parameters snoozy GPTQ model. TheBloke provides some easy to follow instructions right on the page for each model, and I'm going to go right ahead and do that. The look of this page may change by the time you see it, because user interface elements sometimes get shuffled around with updates. Copy the username and model name to the clipboard from the browser, and then paste it into the Download Custom Model or LoRa box at the bottom of the page. Hit download and then wait. You can check the progress in the console window. Once the download is complete, refresh the model list and select it from the list. Set your model options, in this case it will be bits 4, group size 128, and model type llama. Set any of the advanced loading options, for example you may want to set the amount of GPU memory used. Then save the model settings and click reload. You can check the console window to see loading progress. GGML models can similarly be split loaded. llama.cpp is a CPU-oriented library, so here we're going to be offloading to the GPU. Threads should correspond to the number of CPU cores you want to use, and NGPU layers is the number of model layers to load into the GPU VRAM. This will vary somewhat between models, but most 30 billion parameter models seem to have about 60 layers, and most 13 billion parameter models about 40. You'll have to find the optimal number of layers to load into VRAM with a little trial and error, because performance may vary significantly depending on which layers are loaded where. For more advanced options, see the breakdown of command line flags on the TextGen Web UI GitHub page. Kobold CPP is a little bit slow for many of the 13 billion parameter models and above on my system. It often freezes after offloading layers, so I may have to fiddle around with some of the more advanced flags. It does work very well for loading quantized models like the 4-bit models that will fit fully into my 12 GB of GPU VRAM though. You can run the Kobold CPP executable directly, and it will pop up with some configuration options and a model file selector. If you need to use more advanced options, create a batch file with the launch commands like this. This will use 6 CPU threads and force the whole model onto the GPU, which isn't a problem here because this is a 7B parameter model converted to 8-bit weights. Another loading option appeared as I was editing this video. The Kobold CPP wrapper had a feature update that could speed things up for a lot of users, and added support for the K-Quant models. In addition, there's a CUDA build for version 1.30.3, which runs a lot faster on my system. Check the releases page for the changelog and for the most up-to-date notes on feature support. I've linked it down below in the video description. I was intending on doing a segment where I evaluate some of the models out there, but after using a few of the newest 30 billion and 13 billion parameter models, I realized there wouldn't be much of a point. Collectively, we're like 9 months into the AI text generation thing, and I think we've all had plenty of oh-so-clever things that people have made ChatGPT generate. In context, yeah, you can get a lot of inventive output for the task that you've instructed the model to perform, but between models, there really isn't too much difference. Some fare better at maintaining context throughout a conversation or document, some censor output, but that can be worked around by fiddling with the temperature parameters. And an additional issue when evaluating models is that these are functionally random BS generators, and every run is going to be different. Unless one is catastrophically bad, it doesn't really stand out from the rest. A lot of people are excited by the LLM's ability to mimic a conversation when it's fed its output. I wish I could feel as excited as everyone else does about ChatGPT. Maybe I'm too cynical to see the potential. I feel like we've been here before with grand technological claims that never seem to quite materialize into the idealized way they're presented. I'm simultaneously amazed and underwhelmed by these models, which is a strange feeling. I suppose it's the textual equivalent of the uncanny valley phenomenon when watching some computer-generated films. Maybe it's just the general unease that this, like many developments, is going to cause a lot of creative destruction in more ways than one. I also find the personal chatbot relationship deeply unsettling, but I've never been able to easily suspend disbelief when watching a movie or reading a book. Maybe I'd feel differently if I was truly unaware of who or what I was interacting with, but I don't know. But I'm also not going to judge anyone that wants to build their own simulated AI waifu. I've seen weird science. I get it. I should probably cut this here and get this posted, since the longer that I wait, the more I'm going to have to cover as projects get updated and new features get added. I'll probably do a follow-up if there are any big developments, so let me know in the comments if there's anything that you think I should take a look at. Thank you to everyone that's been sharing the videos, and if you found this helpful, please leave a comment or subscribe for more. Thanks for watching, and stay human.